Welcome everybody to the final session number 8. I just have a quick announcement, what I already mentioned before the lunch break. So we will change a little bit the agenda at the end. The reason is because unfortunately we had 2 presentations where our colleagues couldn't travel to Rome, and we tried to connect them remotely, but it doesn't work. So therefore, we only have 2 presentations in session 8. And this is why we move the coffee break after the panel. That's the idea. All right. And with this, over to you, Yves.
Okay, and late breaking news, we actually do have 1 remote presentation, I'm happy to say. So we'll be unfortunately dropping our Ugandan colleague who's not able to present, but we will be having a remote last presentation from Prudence Humanikwe from Zimbabwe. So actually, I'm really excited for this last session, session 8. As you probably saw from our UNICEF team, we're very solution-oriented kind of people, and this is the SDMX outside of statistics session. So I think it'll be an exciting solution-oriented session here that's going to start off. We'll start with Mario Rusev here from DFINE and BIS, who will be talking about applications of blockchain for SDMX. Really, really interesting to see. And then we'll be moving on to Megan Garrick from ILO, who will be discussing the ISSA Stat Data Explorer experience. And then finally we will close with a remote presentation from Prudence Humanikwe on tracing digital penetration using SDMX for spatial data analysis. So all, I think, 3 really interesting ways of looking at SDMX outside of the statistical world. And with that, let me pass to Mario.
Yeah, before Mario starts, it's actually Mario's idea, yeah. And that was like half a year ago. Mario came to us and said, have you ever thought about blockchain and what blockchain could do for SDMX? And we said, yeah, it's a very hot topic. Let's think about this. And so Mario was really the initiator of this and is the driving force. And the idea of this presentation is to test a little bit the appetite here in the community. So it's not something which we have implemented at the BIS. You will see there are some ideas, why could that be useful? And we also have a prototype running, which the colleagues could actually download from an open source repository. But it's all about, testing the water and see whether there's an appetite for such a solution. And if there's an appetite, then of course we could bring the solution into a, let's say, more production state or environment. And we will have a little survey then at the end, which we run, where you can enter your feedback. And this survey actually is something which we keep open for a while, so that you have enough time to reflect what we are talking about today and then see whether it's useful for you. All right, so let's move on. So when we talk about blockchain, I think everybody probably knows what the blockchain is, but let me just repeat again so that those of you who are not so familiar with, they know what we are talking about. So, blockchain is basically a technical concept where you so it's called a decentralized tamper-resistant digital ledger. So what does it mean? It actually means you are storing transactions sequentially in a chain, and then you store them on a large number of servers across the globe. And this has a couple of advantages, because obviously if you just have it on one server in your institution, then the server could fail. Somebody could manipulate the server. So it's already good to have this decentralized approach, because then you don't have a single point of failure. The second thing is that all the transactions are logged. So that means you have full transparency and auditability of everything what has happened in the past. And you can actually go back and verify, why was this happening? So this is something which creates trust. Then you have security. So there are quite advanced cryptographic standards in order to, let's say, store these transactions. There are many different options available. In addition, you have a consensus mechanism, so protocols like proof of work or proof of stake, which basically make sure that these new blocks are only stored if there's a certain agreement. So what is important is there is no intermediary. So there's this protocol, and then once the agreement is there, the transaction will be stored. So again, this ensures that it is a neutral approach. Then in addition, blockchain, as you know, is used in many, many use cases meanwhile. I mean, the most popular one is obviously cryptocurrencies. But I think what is even more important, and I'm talking here because I have a commercial bank background, is actually for smart contracts. So when you execute a transaction, you have a lot of contractual steps happening, and blockchains are used more and more by commercial banks for this smart contracting. So lots of benefits: increased trust, enhanced security, traceability, auditability, greater efficiency, and cost reduction. All right, so why blockchain SDMX? So as I already mentioned, it's all about trust. And you know, there are quite some cases worldwide where actually, trust is a little bit challenged, and let's say we are also challenged, and that means that you know, by applying this very well established technology, we can actually show, this is something you can rely on, and it's generating trust. It ensures data integrity, so it's important. You cannot change the data once they are there. Because of this decentralized approach, the data are immutable. So we have reliable statistics. And it promotes interoperability via SDMX. I mean, this is something to be verified, and that's also where we want a little bit feedback from your side. And I mean, these blockchains, they can connect different systems, so you automatically get this cross-system compatibility. Over to you, Glenn.
Thank you. Yeah. So obviously, I mean, this comes at a cost. This is not free, either in terms of sort of the implementation or running of the blockchains. You know, I mean, there's always costs associated with these things. So what actually is the imperative? Well, I think we all know there's a increasing trend for data consumers to get their data from non-primary sources, from ChatGPT or Google or whatever. And that means that we're beginning to lose control over what's being published in our names. This is obviously sort of what we've heard several times, that you go to ChatGPT and sort of ask it for some statistic, and it comes up with some statistics and cites the sources, and it all seems very credible, except that it's not. So none of this is news as such. But the real problem is that if the data that people are receiving through these sort of alternative channels are wrong, and that could be either accidentally, which is probably sort of the major cause at the moment, or sort of probably more perniciously, deliberately, then people are going to start losing trust, and particularly obviously if the data is distributed through these sort of alternative channels and people are not getting it from these non-primary sources yet, it is still sort of linked back to our institutions, then people will lose trust. And of course, if people lose trust in our data, then it ceases to have value. And of course, this is what George Simon spoke of. I think he used virtually that exact phrase, of course, in his keynote speech. So there is a clear imperative here. So I mean, to a large extent, of course, doing nothing in this data trust space is not an option. I mean, obviously, what we're presenting here is sort of one option out of maybe sort of other options as such. But it's very, very useful to obviously sort of consider this. So just very, very briefly, sort of use cases here. I mean, inevitably situations a bit more nuanced. There's sort of many potential use cases. I mean, here are two, which are probably the sort of the ones which are front and centre. I'll sort of leave you to read the detail of this sort of at your leisure, but I think they can probably be summarised as empowering users to independently verify data authenticity, and on the other side of the fence, enabling us as institutions to regain control over the data that we actually publish.
And maybe before we hand over to Mario, just on this, version authenticity. Quite often we publish corrections to our data in the past. And that is actually one option to verify is the correction first done by the official, let's say, producer. Yeah, that's one thing. And then also, if you want to reproduce your, let's say, analysis, yeah, you are, I don't know, a researcher at the university and you want to reproduce your analysis, is the data set I'm using actually the one which I used 4 months ago? So you can actually go into the blockchain and verify, okay, yes, there were a few modifications, but actually I want to use exactly the same data set what I used 4 months ago because I want to reproduce my result. So this is basically, these are two use cases, sub-use cases, what Glenn just mentioned, just food for thought for you. Over to you, Mario.
Thanks, Rafa. Okay, so I'll get a little bit technical on this note. What we did was we actually created a proof of concept, which will do this, will do exactly this. There is basically a garden of use cases which you can do besides visual authentication. For example, one could be interested in smart contracts which have programmable logic. They have additional authentication capabilities. There's basically algorithms which could put in this to make the whole thing a bit more complex, add features, feature sets, and so on. The other thing is you could also get automated compliance checks and automated validation. For example, if one institution is publishing some data and you don't really need to go through the whole validation process again. So for example, you don't need to run the whole transformations of validation rules. You would need to have a zero knowledge proof, or you could basically run an algorithm that will check this for you. So now, in terms of our POC, what we've built is an algorithm or a product or a little POC product, which would take an STMX file, an XML file. Then it will get its hash. So it's a SHA-3 hash. Of course, this needs to be canonicalized to remove insignificant white spaces and so on. And then it will publish this particular file hash onto the blockchain as a memo transaction. Obviously, you could do Merkle tree aggregation. So for example, if you have many files or many series of the same file and you would want to put this together or have some sort of decentralized identity on top of this, this could also work. We've also considered these whole things, how to do this mathematically and computationally. It turns out it scales logarithmic with the size of the Merkle tree. So this means you could easily have verification time over a second, a bit over a second, for millions of data sets. So here we're looking at automated verification of this whole structure, which can be integrated into AI agents and model context protocols easily within a second. And our publication time, which we are using here, is just from the XRP ledger. This could be any ledger. We're here blockchain agnostic, but this one's very green. Publication time is about 3 to 5 seconds, and we also ran some tests. Now, I also want to mention there was a recent publication from the US Department of Commerce that they are putting data points such as the GDP, the PCE, and consumer price index on a Chainlink node, so on the blockchain. They put just the data points. What we're doing here is a fully fledged STMX system and compliant with STMX. And right, and then a bit about the costs. We also have a model to model all the costs necessary. So there's on-chain transaction costs. In this case, I'm just showing a linear plot with a particular reason. Now, if you consider proof of work or proof of stake, you would see that costs are not constant. So there's basically dependent on how many validators are there and the whole approval algorithm and so on. With this blockchain, they are constant. So anytime you have a transaction, the cost is constant. So this limits the transaction costs. It basically gives you a very, very reliable estimate of the on-chain anchoring costs. Then you have the off-chain storage and retrieval costs, the processing and orchestration costs. And another thing I would consider the economic time of delay or latency. Now, considering this whole thing, we also built a model to test this whole thing out. And I'm not sure if you can read it down. There's a little table to compare these whole things. Right, so we are looking at fixed costs for validation, which are well below a cent. you know, compared to Ethereum or Chainlink or Bitcoin or whatever. Normally, you would have a digital authority certificate, thanks, Rafa, you would do this process manually. So if you want to make sure that an institution has produced a particular data set, you would have to trust a particular anchor to do this, or a GitLab. This is in comparison to quantum credentials. You don't really trust anybody here. The whole thing is automatic. It's on the chain, so you could ask it anytime as an independent reviewer. No data is on the chain. It's only the hash, so you can't really get any information about the data set if you cannot crack the hash function. And there one last point I want to make. We have also considered how to make this quantum sure. You know, there's a lot of chat about quantum computers and RSA algorithms and things like this. Now we use SHA-3512. You can obviously do the same thing with a lattice problem. For example, a dilithium approach. This would be no issue. So we can do this as well. And I think that I'll just go to the video. We have a little, I don't know if you show. I mean, we can show the video, or I could just show the snapshots. Okay, so here on the top left is basically a fast API in Streamlit, so microservice plus a GUI. We have an XRPL gateway. We are using also a bit of util functions and things like this to make sure the canonicalization is robust, and do a bit more math on this. Then you can get a file, you publish the file, we write on the next image, on the top of the published file, we write the transaction hash into the source header information of the file. So then you can take this file and distribute it wherever you want. And again, for the verification process, you're taking this file. Since the transaction hash is on chain, you would get the file, do your hash yourself, compare it with the on-chain transaction memo, then the file is valid or invalid.
Okay, so you see, it's quite technical, yeah. I think there's one message, if I can just come back. If you look at this table below, we actually have a very cheap solution for this. Yeah? When you look at the Ethereum cost, our implementation is far cheaper. So when you think about implementing this, have a look at our solution, how we store the things in the blockchain. There's some thought on that, which will save you a lot of cost. So that's the first message. And then, yeah, as I mentioned in the beginning, the question is, what do you think about this? Is this useful for you? And let me just reiterate again the three main use cases here. First use case is, with a blockchain, you get, let's say, an unimmutable stamp who the golden source of this particular data point is. And this is particularly relevant if your data are used by commercial data providers or other organizations, and they basically redistribute this. You can basically then always, as a final consumer, go back into the blockchain and you see, it's Eurostat who produced this. Eurostat is the official producer and you cannot change that. That's the golden source. That's use case number one. Use case number two is, since we are making a lot of corrections of our data on the public website, but we actually don't store all the history on the public website. Yeah, we are not storing all the vintages. I mean, some of you, but not all. The blockchain will enable the final consumers to always roll back to the point of how was the data 4 months ago, because I want to have reproducibility of my results. And the reason why we don't put all the data, all the, let's say, history in our data portals is because it's very costly. Yeah. So that's the second use case. So think about this. Is this something which your customers, your users are interested in? And then obviously the third one is, it's all about trust. You can be sure that this data point is linked to a log entry, the full history, and it cannot be changed. You know exactly what happened in the past. And if somebody manipulates the data, it's almost impossible. Yeah. So these are the three things. So we want to know, is this relevant for you? would your organization be able to implement this? Do you want to collaborate with colleagues? If yes, with whom? And for this, Glenn has a Slido, and this is the QR code. And this is the QR code for the Wi-Fi, the alternative Wi-Fi. You remember yesterday we had some issues, yeah? So if you have not yet logged in into this, please scan it, and I give you 10, 20 seconds to just connect for those who have not already done this. And then on the next page, you will see the QR code for the Slido. So let me just see. Just one more. Okay, so this is the QR code for the Slido. So scan it, and how long do we keep it open, Glenn? It's here until the 9th of October, yeah. So you have time also after the conference to fill this, have a discussion with your colleagues, and we are more than happy from a BS perspective and also from a Define perspective with Mario to follow up with you if you need more information or if you need a partner to implement this. Thank you very much.
Thank you so much, Raphael, Glenn, Mario. I think it's an idea whose apparent complexity is also, I think, matched by its power in a world of fake news and alternative facts, and many of us charged with producing official statistics. Techniques like this, I think, become ever more important. Thank you. Passing on now to Megan Garrique from ILO with the ISSA Stat Data Explorer. And you may want to use the screen over here for ease of reading.
I'll get your help. Oh, okay. Okay. So I'll be presenting on the ESA database on international social security agreements. So the ESA is a bit of a strange creature. We sit within the ILO, but we're actually a separate organization with our separate budget and program. So we bring together various national social security administrations, and why it was created by the ILO, because Social Security is a bit more complex than a lot of the other fields of labor regulation. You need to collect contributions, pay out benefits, etc. In terms of our data, we did this project in collaboration with the Statistics Department of the ILO. Edgardo and Wenchen particularly were very crucial in helping us. And I guess why they both encouraged me to come to this conference is a very unusual application of SDMX. In the ESA, a lot of the statistics related to Social Security are actually collected by ILOstat or the Social Protection Department. What we collect is rather mostly policy data or administrative practices. And so we have various databases, and one of them is on international social security agreements. So I'll go fast at the end, so I'll go slow at the beginning. So what is an international social security agreement? So this is a formal treaty between two or more countries to protect the rights of people who move across borders for work or residency. And so these agreements are crucial for migrant workers, retirees, and international employers to ensure the fairness and continuity and social protection. So, for instance, they ensure the accumulation of years worked in two or more countries to fulfill the qualifying conditions for pensions, for example. So what do we collect in this database? So we're looking at bilateral and multilateral social security agreements that have entered into force. So with a European context, Regulation 883 is probably the one that comes first to mind, but there are a lot of also bilateral agreements. Actually, there's 650 such agreements in our database. And so it's why we decided to start with this. We have 4 other sort of policy or administrative practice databases, but this one is very simple. So we have the basic information, which is the countries involved and the dates of entry into force. Exemptions for posted workers. So what's a posted worker? Let's say Coca-Cola wants to send John from the US to Italy. He's technically working for a US company, but working in Italy. So to avoid that he pays the contributions in 2 countries, there's an agreement that says that they're exempted for 2 years or 5 years, etc. And then facilitated access to benefits. This is rather usually it usually concerns pensions. So usually there's a minimum qualifying period. You need 10 years of contributions to qualify for a pension. And if you're a very mobile worker, there's the chance that you haven't accumulated this in 1 country, so you can add them up. Third country totalization is pretty simple. It's what it sounds like, just adding it up with a third country. And so the process to date, we had data collection by region. We also have Social Security profiles that look at the policies on the 9 branches of Social Security. So we integrated the collection with that. Together with Edgardo and Wenchen, we developed a pilot user interface. So using SDMX as the statistical model and using the .stat suite data explorer. And perhaps what's interesting for you is that we presented this pilot interface to ESA members and received overwhelmingly positive feedback. So it's an interesting case. So if you look here, here's an example of the .stat interface. You can see on the left, there's just for instance, this is for Canada. Canada is one of the countries, together with Korea, that has really a lot of bilateral agreements. And so you can see the identifiers on the left, who the partner country is, the date of entry into force, and we also have an agreement identifier. Then the number of months that different workers are exempted, and then this is just a binary yes/no in terms of which branches are covered and whether you allow for third country totalization. So you can see, let's say in the case of Canada, that it's overwhelmingly pensions, old age, disability, and survivors. So yes, this is a non-statistical SDMX application. And it's part of an ongoing collaboration between the ESA and the ILO, which I'll get to at the end. These next slides just show you what it looks like. So this is the Data Explorer. And the features that are relevant for statistics are also quite interesting for a policy database. So for instance, here we've been able to integrate the link to the agreement text. In some cases, it depends per agreement, but there's usually the agreement text and then also the implementation agreement text, so it's two laws, and then notes. I won't go through this in too much detail, but our members were impressed with the possibility to select multiple countries, to change the layout, and to have identifiers so they can map it and to download. The feedback we got was that it was easy, intuitive, well-structured, efficient, user-friendly, smooth. And for us as the ESA, what's really interesting is how quickly you can go from database to dissemination, with very, very confident help modeling, but yeah. Another project, so if you think of these international agreements, if you have a mobile worker, and he's receiving a pension, so partially, let's say from Canada, partially from Italy. Eventually, if their situation changes, for instance, residence, life status, etc., you want to stop paying that pension or change it to a survivor's pension, etc. So a second SDMX application that we're exploring together with the statistics department of the ILO is using SDMX for data exchange. So the criteria for establishing eligibility is personal data, residence status, worked periods, total worked periods across countries, and other information. And for payment continuity, it's life status, income and residence, and other information. So ESA is exploring using SDMX to standardize different data types and support data exchange operations. So the DSD to model the data types, prioritizing for now life status validation and standardized data flows to help data exchange. One thing that isn't within the SDMX current functionalities is privacy and security measures. So we're using a third-party provider to encrypt the information. And so what it would look like, let's say Italy's INPS. They know the ESA format. They can download the data that's been converted into this format, then convert it into their nationals and check the records and vice versa. So it's really this exchange function. And yeah, so the next steps before we go piloting, we're just updating data, activating the multilingual features, and we're exploring, of course, the data exchange. And that's it. Thank you so much.
Thanks so much, Megan. And I know many of us always struggle with meeting the data visualization needs of our users. Many times we don't even ask them. So congratulations for working to get so much feedback from your user base. Now we'll be moving on to the third presentation from Prudence Humaniqua. This will be a remote presentation. So I'm counting on our colleagues here to get a WebEx up and running. And then I believe I'll be moving these slides along. So.
Good afternoon, everyone. Can you hear me?
Good afternoon, Prudence. Thanks for joining us. I'll be moving the slides along for you. So just let me know next slide whenever you require one.
Okay, thank you very much. My name is Tsitsi Prudence Somanikwa from the Department of Geography and Geoinformation Science under the Faculty of Humanities and Social Sciences of Lupane State University in Zimbabwe. Today, I'm going to be presenting on how I utilized SDMX data in my line of work as a GIS professional. The title of my presentation is an exploratory spatial data analysis excuse me, of e-government and e-participation across Africa using SDMX data. May we go to the next slide? Okay, just a background to the study that I did. We know that socio-economic digitalization significantly contributes to sustainable development on a global scale all the way to local scales. However, digital divide remains a barrier to equitable progress towards the SDGs. Therefore, targeted interventions involving the digital economy are critical for reducing inequalities according to the SDG 10 and partnership for the for all the SDGs according to SDG 17. And digitalization is a major driving factor for globalization. Hence, we need to find ways to bridge the digital divide. This study combined SDMX data, the standardized format for statistics, as well as GIS data under the domain of geography for generating actionable insights on the digital divide across Africa. May we please move to the next slide? Okay, my study area was Africa, all the 54 countries of Africa is presented on the map. Can we move to the next slide? Okay, as I'm sure is reiterated before, SDMX is a statistical data and metadata exchange, which is the global language for official statistics. Therefore, it provides a standardized framework for describing and sharing statistical data. In this presentation, I leveraged SDMX to do the exploratory spatial data analysis looking at e-government and e-participation across Africa. Whilst I did not use APIs, I used pre-packaged SDMX datasets. I was through the standardized format of SDMX, I was able to easily integrate and interoperate various tools and technologies, such as the Quantum Geographical Information System, the GeoDA software, and Google Base Maps, therefore eliminating data harmonization error barriers or errors through which are often associated with manual entry. And there is also the advantage of scalability and reproducibility, since one can repeat the same workflow for many other indicators beyond the digital measures of e-government and e-participation. And I believe that there will be repeatability as new SDMX releases come out. Shall we move to the next slide? Okay, so how did SDMX enable my my spatial analysis? As I've said before, the looking at point number one, the SDMX standards, it allows for comparability, and which is cross-country comparability, which is critical for continental analysis. Therefore, instead of manual cleaning and manual entry of data, I could easily do an attribute join in a geographical information system the between the SDMX data and the shape files in order for me to do the mapping so that I can review the policy relevant patterns and conduct a more complicated exploratory spatial data analysis as will be presented in the annex file. May we please move to the next slide. Okay, the ESTA is or info exploratory spatial data analysis. These are the crucial set of techniques used to describe and visualize spatial data. So I'm looking at the statistics of e-government and e-participation, but across space, specifically the 54 African countries. We are unveiling the patterns and disparities across space that might not be immediately obvious. So in this presentation, I'm only going to present the chloropleth maps, but then in the annex file, I've presented the univariate and bivariate global Moran's eye and as well as the local Moran's eye. I'm sure it will be available after the presentation. Shall we move to the next slide? E-government or electronic governments assesses a country's digital transformation, or should I say penetration, by measuring based on the three factors, which are online services, telecommunication, and human capital. So we note that in the local quantile for the African countries, we've got Western Sahara, which is a non-self-governing territory, and countries in the Sahel region, and the Horn of Africa, such as Somalia and South Sudan. And then in the upper quantile, we have newly industrialized countries in Africa and some developed countries such as South Africa, Botswana, and Eswatini and Kenya. So I move to the next slide. And then e-participation it measures the uptake of the e-government initiatives. It refers to the use of ICT to enhance and enable citizens' involvement in government and policy making processes, making them active partners rather than passive information users. Similarly, in the lower quartile, we've got countries in the Sahel region, but it's somehow extending to the Sahara deserts, with countries such as Eritrea, Western Sahara, Comoros, and so forth. But then in the upper quintile countries again, South Africa remains a leading country in Africa in digitalization, together with Tunisia, Togo, and Egypt. So we see that the spatial disparities, they are variations in in the policies pertaining to socio-economic policies pertaining to e-government and e-participation, for example. So in conclusion, shall we move to the next slide? In conclusion, adapting SDMX goes beyond data exchange, but it's also about making data actionable, and it is essential. It was in my case, it was an essential step towards advanced techniques such as SDA, I mean ESDA, to create evidence-based policies for e-governance in Africa. So it bridged the gap between statistics and my domain of geography. Therefore, SDMX compliant data portals should include geospatial information, and we advocate for the use of SDMX standards. I thank you.
Thanks so much, Prudence. It's great to see the increasing use of spatial analysis of SDMX data. And if you could stay online while we're doing a general Q&A for the panel, in case some questions come in on your work, that would be great. I should also mention that Prudence has included an extensive annex on the methods that she used, which will be, I believe, available on the proceedings of the conference. And with that, I think we have perhaps, well, I leave it to our organizers, but 5-10 minutes for Q&A. Shatong.
My question goes to the colleagues from BIS. I'm interested about this blockchain. Really, like to me, it's actually the first time to see how we can use the blockchain to transfer SDMX message. So I want to get a bit more details to how you do the encryption, and also like when the receipt side, how you to receive it and decrypt it, the message, and a bit more maybe on the infrastructure requirements, you know, like what are the storage needed and something to give more details. Yeah, thank you.
I don't see any other immediate hands raised, so perhaps, oh, except for Abdullah down there.
Yeah, my question also goes to BIS. It's very interesting and very, I mean, a presentation that caught me by surprise. But the use case I have in mind is, I think it's, maybe I'm wrong, but I think it's slightly different from what you mentioned, because you mentioned that, well, Eurostat is the golden source, and now you can trace it back to Eurostat. But the thing is that Eurostat is almost certainly not the golden source. Most likely the figure had come from one of its member states, right? That would be the golden source. So what the use case I have in mind is how to trace the figures as that they may transmute along the way. They may be adjusted, for example, for international comparability. Usually, this type of, I mean, usually to understand how these figures were obtained, reference metadata are used. General enough. It's very difficult to, to understand how the figure was produced. That is a source of controversy, particularly between countries and international agencies. So I've never thought that this could be addressed through anything other than, well, I thought that this would be really a tough call to use anything other than reference metadata to address that. But if blockchain or can be used to address that, or crypto or something, that would be really interesting if you could say a few words about that.
And we'll take one more from Edgardo. Oh.
Yeah, thanks. Just
okay, Luis then.
Very quick question also for BIS team, but related to Megan's presentation, because if you noted in the second project that ESA is using SDMX4, that is the exchange of information about termination of services or benefits between countries. One of the issues, not solved issues yet with SDMX, is the authentication and encryption of the message. So I know that blockchain provides much more than that, but my question is whether you think that using blockchain for exchanging ACMX data could be a reasonable and affordable solution for encryption and authentication only, just talking about this benefit.
Okay, just a comment on the last presentation from Prudence. On the index, on the map, she noticed that Ghana did well, but what is written, Ghana is written on the map of Cote d'Ivoire, Ivory Coast. So maybe you need to check if it is Cote d'Ivoire or Ghana. So.
We'll leave that one for Prudence to be able to answer. But let's start with the 3 questions on blockchain to start with.
So, Mario and Glenn, you will please complement. So I think on the, methods to, let's say, decrypt and encrypt and decrypt, yeah. Indeed, it's not easy to basically choose at which level do you want to create the, let's say, the hash. Is it at the time series level, at the observation level? Is it at the submission, at the data set level? So it depends heavily on the use case. Yeah, everything is possible, but that's something you need to decide before. And obviously the complexity increases, yeah, the more granular you go. Yeah. The other thing in terms of the technology, what is it we are using? I mean, basically Python. It's a Python implementation, and Mario will say maybe a little bit more about the blockchain, because we actually analyzed, I think, 10 different or even more different blockchain setups. And as you see, one of the main driving forces was actually the cost, because we said, if you want to offer an implementation in our open source domain, it needs to be really cost effective. And I don't know whether some of you deal with cryptocurrencies, but if you invest in Bitcoin, for example, at the moment, the transaction cost is actually quite high because energy consumption, and also there are not so many blocks left. So this is why we actually spend quite a lot of effort to find a solution which is really affordable. And I think this is one of the main contributions, I would say, of this proof of concept. So if anybody's interested, and by the way, I just heard actually that Eurostat is also investing in a similar project. So obviously there seems to be demand. So I suggest look at our implementation, because it might save you a lot of money. And I'll let Mario complement a little bit on that before I move to the next point.
Thanks, Rafael. Right, just a bit of complementation. What we've built here is a fast API microservice plus a Streamlit UI. Now, the Streamlit is irrelevant. You can do this onto any corporate platform. You could take Angular, you could take whatever. You could put many different UIs. The key point here is the microservice is so more or less like a microservice as a verification for humans and AI agents, right? So the thing is, it's very performant. As Rafael mentions, we've looked at different setups. There are also other blockchains which have even lower costs, but then you have to think of what is the algorithm that's behind this. Like the only thing that's really contrasting here with content credentials, like if you look into this field, content credentials, you have to sit on a GitLab server or on somebody, you have to trust somebody, that whoever is the source of this repository, that they say who the originator is. Now here, you've recorded a transaction immutably on a ledger, and anybody can recreate the hashing if they have the file, right? So now we're using SHA-3512. This is just an algorithm in terms of attribute ordering and so on. You can make it such that attribute ordering would be relevant, or namespace collisions. There's also a combinatorial attacks. We've considered all sorts of things. So you can make this thing very, very efficient in terms of publishing and in terms of verification. The publishing time of this particular version is about 3 to 5 seconds. So ideally, we wanted something that's about 5 seconds. in a verification more or less like a real-time verification, which also enables nowcasting, all sorts of other use cases. Now, in terms of this microservice would be just sitting somewhere. It's an API based, right? So it's a request response thing, but you could also make it Kafka-wise, let's put it this way. So you could integrate it anywhere. But it's on development, so we're using a development node for this. Obviously, you can't put it right into production, but it's pretty much the same thing what you do in production, right? And the thing is, you can integrate this to almost anything and make sure that verification scales logarithmically with respect to the size of the Merkle tree. So meaning if I take 1 million or many millions of hashes, store them on a Merkle root, then it will still take me a second to verify this. And then you can do zero knowledge proofs on this. Basically, you could say with certainty if a particular transformation or validation was used and performed without doing it yourself. So that's another benefit. I mean, there's really, I don't know, plenty of use cases about this. We just took the first ones. And the whole point is we've had all the algorithms. We see that they're efficient. Cost-wise, we've have all the costs. We even have a model which will tell you if to batch, when to batch, how much to batch, and so on. So these are all things considered. But in terms of technology, you could write this also in Spring Boot. I mean, I don't really care about the language. So it's very easy to use. It's very straightforward. But on our POC side, it's a fast API.
Right, and maybe to come to the next question. So, traceability. Data are being collected by the National Statistical Agency, goes to the, international organization, goes to the next. This is exactly a use case for blockchain because, when you think about smart contracting, it's nothing else. Smart contracting in commercial banks, actually, you have like 10 different intermediaries before a contract is really signed. It goes from the front office to the back office to the clearing agency, etc. And at every step, somebody modifies something. It can be something in the contract. It can be maybe adding some additional information. And this entire chain is actually stored in the blockchain, and all the benefits which we listed today are available. So I think it's an opportunity for official statistics to actually make use of this technology because there are plenty of these technologies or options available. It's cheap, it's fast, as Mario said. I think I'm surprised that we have not really used it yet. So answer is absolutely yes. Glenn, Mario, want to add?
Just one more thing. I remembered there was a question about storage. Now, normally, if you look at a classical world and you want to send data from point A to point B, you have to worry about sending large volumes of data. Then the other institute's going to check this data, run their rules, and validation rules, logic. There could be, I'm not saying we should implement smart contracts in our product. We're just using SRP for the memo, and we're memoing an object, right? So if you want to do complex use cases, there might be other networks to consider. But we have a model to calculate all the costs automatically. And now you don't really need to send this many of objects. Now you can have your S3, or your database, whatever storage you want, data lake, you name it, in your institution, and you're just sending basically practically 2 kilobytes of hash from one point to the other. So assuming we could do also the zero knowledge proof use case, then you're really sending 2 kilobytes. So now you can think in terms of immutable dashboards, right? There's, if you have the GDP, consumer price index, all sort of these things on the chain, then you could be thinking about inflation-linked products, credit links notes, derivatives, all sorts of stuff that can spin off from this. And then dashboards powered by these immutable data sets. And even because it's so fast and you're sending so little data, then this whole business of anomaly detection from agents and nowcasting and all sorts of stuff, you could do this in an edge AI, and this will practically take you a few seconds. So that's another benefit.
Yeah, just to pick up on this sort of question about, I think the question you asked, Edgar, which is about trusted lineage. I mean, this is a bit of a holy grail. And of course, I mean, when we sort of started looking at this, of course, you know, some of the alternative options, of course, Mario sort of outlined was content credentials. And in the digital media space, this is a big issue, clearly, as well, to the extent that, you know, videos and, you know, digital reports and things which are sort of kicking around, users and news agencies, you know, need to know where these things have come from. And within that space, they're looking very closely at content credentials and the standard called CP or C2PA, I think, which is sort of emerging. It's a collaboration between Microsoft and possibly Google and the BBC in the UK. But the advantage here is obviously the blockchain is precisely, I think as Rafael laid out it, this ability to also hold this chain of trust. So this is another really good example why blockchain actually works really well here.
I'll just jump 2 sentences more because I remember there was also a question about cryptography. And I'll tell you a bit about cryptography in 2 sentences, or I'll try. Now, this whole SHA business, what it's doing is taking a big integer, and it's looking if it's a combination of 2 prime integers, right? Now, I also had some experience with quantum physics, and you see there's quantum computers on the rise, and it seems like these kind of problems are easier to solve. Now, the benefit of a blockchain is you can make sure that a particular transaction is signed by a private key, right? Now, here we use an example, a SHA-3512. So it will take a very long time for a quantum computer to break it, but still. And this will be no issue. This is really no issue to change the algorithm to another more complex algorithm where the quantum computer can't solve it. So, for example, there's several problems. One example is a lattice problem, you know, solving a lattice problem with the lithium particle and so on. So this is something we've also considered.
Thank you. I hope we adequately answered those questions. I'd like to check if Prudence is still online with us for Lewis's question. Prudence.
Yes.
Yes. Okay.
Thank you.
Lewis, I don't know if it would be good if you could rephrase your question, but I understood that you were questioning the mapping sources between Ghana and Cote d'Ivoire that were used. Can we get a microphone?
You said Ghana did very well.
Okay.
Thank you. We'll check that in the data annex that we get provided as well. Let's see, where are we at? Well, we're at 3 p.m. I think we should probably close it down. I have one quick question, though, that I would like to ask to Megan, which is, since you got all this feedback from your users, what was the number one thing you wish you could provide them from going from SDMX, let's say APIs and data sources into the visualization user space?
Well, I think one thing that we came across was that our data set surprisingly was quite large because there's the 9 brands.